Today we're going to talk about differential amplifiers. Why is it important sa mga operational amplifiers? Dahil ang differential amplifier is the first stage sa loob ng isang operational amplifier or op-amp. So as you can see here, this is the basic circuit for the differential amplifier or yung tinatawag natin na diff amp. Meron tayong dalawang NPN na BJT. So ang itsura nila is face-to-face or magkaharap sila. We have RC1 and RC2 which are identical, and we have RE on the emitter terminal. Let us assume that the two transistors are identical. The differential amplifier also has two inputs. So we have input number 1 and we have input number 2. And it also has two outputs. So output number 1 and output number 2, kinukuha natin sa collector terminal ng ating BJT. We have two power supplies. So they are dual polarity. We have plus VCC and we have negative VEE for the power supply. And here are the currents. Okay, so let us call this IE1. Let us call this IE2. Assuming that both of the transistors are identical, IE1 is also equal to IE2. So we have also a current that passes through RE. So we can call that IRE. But how do we relate IRE and yung ating dalawang IE? So we have IE1 plus IE2 is equal to IRE. Since yung dalawang current natin, IE1 and IE2, magsasalubong dun sa ating node, and it will combine to produce IRE. We can write the equation IE1 plus IE2 is equal to IRE. And since the two emitter currents are equal, we can write it as IE plus IE is equal to IRE, which gives us 2IE is equal to IRE. Therefore, IE is equal to IRE divided by 2. In order for us to understand how a differential amplifier operates, kinakailangan natin lagyan ng input yung ating input number 1 and yung ating input number 2. So we have two conditions. So the first one would be input number 1 is grounded or directly connected to the ground or zero potential. Input number 2 is also grounded or connected directly to the ground. Let us now isolate this part from the differential amplifier. So itong part na to, in-isolate natin, nilagay natin dito sa part dito sa baba. So the collector is temporarily disconnected from our circuit. Since yung power supply natin, VEE, the negative VEE is connected to one terminal of our RE, the equivalent is this one. So yung negative connected doon, and then yung positive is connected to the ground. So as you can see here, since the positive terminal of VEE is connected to the ground, it's also connected to your base. So they have the same potential. So let us determine if it is forward bias or reverse bias yung ating base to emitter junction. So positive, then connected siya dito sa base. So we have a positive polarity here and negative dito sa ating emitter. Therefore, it is forward biased. Then we will have a base to emitter DC voltage on that part. And next, we have a current na dumadaan sa ating RE, so pababa. Kanina, we determined that as IRE. So this is our equivalent circuit for this part. Now we can write down the KVL equation, and let us do that clockwise. Writing down our KVL equation. So we have positive VBE, and then plus IERE, and then we have minus VEE equals 0. VBE can also be rewritten as VB minus VE. So we have plus IERE minus VEE is equal to 0. So we know that the base is directly connected to the ground, kaya po pwede siyang ma-cancel dahil 0 yung kanyang voltage or potential. And our objective here is to get the equation for IE. So rearranging the terms, the terms of the equation. So we have IE is equal to VE plus VEE divided by RE. Having this equation, we can replace the value of VE by another value. So tignan natin ano ba yung voltahe across VBE. Since the base to emitter junction is forward bias, alam natin na meron siyang 0.7 volt na potential. So if we're going to measure it here, for example, we have a tester. This is the positive test lead and this is the negative test lead. So pag measure natin ganyan, we will more likely have a 0.7 volt potential. But what if we measure it from the emitter terminal? So maglalagay tayo ngayon, nandito yung ating positive test lead, and then nandito yung ating negative test lead. So this is essentially VE or the emitter voltage. Now this is equal to 0.7 volt. We can rewrite this equation, so let us just write it on top of this circuit. So we have IE is now equal to negative 0.7 volt plus VEE over RE. So you'll have to excuse my board no, kasi maliit siya, kaya medyo cramped up yung ating pagsusulat. So this is our equation. IE is equal to negative 0.7 volt plus VEE divided by RE. Now let us determine the equation for the output voltage taken from our collector terminal. Pwede tayo mag-focus sa isang part lang. No? So it's either on the left side or on the right side. So let's choose the left side. So the output here is taken from the collector. So we will call that output number 1 or output 1. This is essentially our collector voltage. So this is the collector with respect to ground. And then you have RC1 and then you have plus VCC. We can redraw the equivalent circuit for this one, isolating this part from our differential amplifier. We can have this equivalent circuit. So nakahang muna yung ating emitter terminal. Okay, and then we can now write down the proper polarities for the induced voltages. We have plus, minus. Okay, and then yung kuryenteng dumadaan kay RC1, pababa. Of course, this is your IC. Let's call that IC1. Okay, and then the output is taken from the collector terminal. So this is output number 1, but this is essentially your DC or collector voltage. We can write down the equation for the output number 1. So magsisimula tayo dito sa part na yan. No? So we can write it down as VC equals, so we're just going to trace no? From that point papunta dun sa ating ground. So ang unang dadaanan is negative. So we have minus IC1 times RC1, and then dadaan ko dun sa positive ng VCC plus VCC, and then ultimately we will reach the ground. So this is your equation for the output voltage V sub C or VC. How can we express this equation, particularly this term, in terms of IE? So kanina, na-derive natin yung relationship between the emitter currents and yung IRE. Diba? So kanina nilagay natin dito, we have IE is equal to IRE over 2. Okay? And since I sub E is approximately equal to I sub C, we can replace this in our equation. So we have now E sub C is now equal to IE, negative IE. It's either IE1 or IE2. There's no problem kasi the transistors are identical. The same with RC1 and RC2. And then we have RC1 plus VCC. We can replace IE by IRE divided by 2. So we have VC is equal to negative IRE over 2 times RC1 plus VCC. So let us rewrite this equation in a manner na mauna yung VCC. No? So we have VC is equal to VCC minus IRE over 2 times RC1. So this is our working equation in order for us to determine our output voltage taken from the collector. For the second condition, instead of meron tayong dalawang input na directly connected sa ground, meron tayong isang input naman dito na merong positive amount of base voltage. So let's say for example, input number 1 na lang. So maglalagay tayo dito ng positive potential sa base terminal. So this is the second condition. No? And input number 2 is left grounded. So naiwan yung ground, na nakakonect yung ground sa kanya. So mag-focus muna tayo on the transistor on the left side. Since meron tayong positive potential sa base, it is more forward biased compared to the first condition. Since this is more forward biased, it means that the base current na pumapasok dito, tataas. Pag tumaas yung IB natin dito, it means na yung collector current natin dito ay tataas din. Therefore, tataas din yung ating emitter terminal if we're just focusing on the left side. Okay? So, isa-isahin uli natin. No? For this one, the DC base current will increase. The same with the collector current. And then the same with the emitter current. Okay? Since the emitter current has increased, ibig sabihin, tataas yung voltahe ng R sub E. So, tataas yung VRE natin. Okay. Since tataas yung VRE natin, tataas yung ating VE. So take note of this kasi this will be useful pag diniscuss natin yung nasa right side naman. Okay, next. For the right-hand side of our differential amplifier, since tumaas nga yung ating VE, what will happen to the applied potential dun sa ating base emitter junction? Since tataas to, and this is still connected to the ground, so it will be less forward biased compared with the other. Tataas yung VE, magiging less yung kanyang bias. Kapag less na yung kanyang bias, bababa yung IB, bababa yung IC, and bababa rin yung IE niya. So let us write down the characteristics of the right-hand side of our diff amp. So forward bias is reduced. Therefore, IB is also reduced. IC is also reduced, and the same with IE. So, ano magiging epekto nito sa ating output voltages? So, mag-focus muna tayo on the left-hand side wherein nag-apply tayo ng positive bias dun sa ating base. Okay? So, ito yung nakuha natin kanina na equation to determine the output voltage VC. Ilagay natin dito sa left-hand side, no? Para ma-analyze natin yung magiging value or property ng ating output voltage sa output number 1. So we have VC is equal to VCC minus IRE over 2 times RC1. So on the left side of your circuit, tumaas daw yung ating IC. Okay? So tignan natin kung ano magiging effect dito. Remember, IRE is a direct function of IC. So kapag tumaas to, ibig sabihin, ang magiging total natin, bababa. So VC will decrease on the left-hand side. Ibig sabihin, ang output number 1, which is also equal to your VC, will also decrease. Okay? So ulitin natin, no? Yung positive potential dito sa base, ultimately, will lead to a lower output voltage. Tumaas yung input, but the output bababa. On the right-hand side of your circuit naman, ito yung merong grounded na input natin. No? So, analyze natin. Bababa daw yung IC natin. We know that IRE is a direct function of IC. So, since bababa ito, what will happen to VC? Tataas. So, therefore, increase in VC will lead also to the output voltage number 2, will also lead in an increase in OP or output number 2. The same analysis is also true kapag pinagbaliktad natin. So for example, yung input number 1, i-connect natin direkta sa ground, and yung input number 2, maglalagay tayo ng positive voltage VB. That's why I've said earlier in this video na we have two conditions. Okay, so that is how the differential amplifier works. We will have an example for this. We will compute for the different DC parameters ng ating differential amplifiers. Let us now go to the example. We have a differential amplifier. So ngayon meron na tayong mga values. We have 3.9 kilo ohms both for RC. We have 3.3 kilo ohms para sa ating RE. We have plus and minus 9 volts for the supply. Meron tayong AC inputs. Okay? So, our task here is to find the DC voltages and the current. So, yung mga dinerive natin earlier in our discussion, yun yung gagamitin natin na equation to solve for the DC parameters of this differential amplifier. First, let us solve for IRE, which is the current that passes through your 3.3 kilo ohm resistor. So this is your IRE. Ang nakuha nating equation earlier for IRE is IRE equals VEE minus 0.7 volt divided by R sub E. We can directly substitute the values. VEE is equal to 9 volts. So bakit hindi negative 9? Kasi negative 9 is negative VEE. Okay? That's why VEE is just equal to positive 9 volts. Alright? Minus 0.7 volt divided by 3.3 kilo ohms. So IRE is equal to 2.5 milliamperes. So we have a 2.5 milliampere current na dumadaan dun sa ating 3.3 kilo ohm resistor na R sub E. Next is we're going to solve for I sub C or the collector current na dumadaan dito sa ating 3.9 kilo ohm resistors. So kanina, ang ating equation for I sub C. So that is equal to I RE over 2. So we have 2.5 milliamperes divided by 2, which is equal to 1.25 milliamperes. And then lastly, we can determine the output voltage VC. So pareho lang yung ating magiging output voltage. Since they are identical, yung ating transistors. Okay? So our equation for VC, or the output voltage, so let us just write it on this part. So we have VC is equal to VCC minus IC RC. And then just directly substitute the values. We have 9 volts minus 1.25 milliamperes yung value ng IC na nakuha natin kanina. So we have 1.25 milliamperes multiplied by 3.9 kilo ohms, which will ultimately give us 4.1 volts for the output. So hanggang dyan muna tayo for today. I hope you understood the basic operations of a differential amplifier, kasi importanteng maintindihan natin kung paano gumagana ang diff amp, because as I've said before, this is the first stage of an operational amplifier. If you have any questions, just send it to me to our group, and hopefully I can answer you back right away. So that would be all. Thank you.